Namaskara. Today let's learn about CMP sensor, that is camshaft position sensor. From the name itself we can understand this sensor is responsible for measuring speed and position of the camshaft. But what is camshaft? That is, camshaft is a mechanically machined component which is responsible for opening and closing of the intake and exhaust valves. In modern engines we will have two camshafts, that is, one is for intake valves and another one is for exhaust valves.
A few inches later.
Here you can see I have drawn two diagrams. One is side view and the another one is top view. In the side view, these two are camshaft. The first one is intake side camshaft. The second one is exhaust side camshaft. These two are camshaft position sensor. That is, CMP1 is for intake side, CMP2 is for exhaust side. And this part is crankshaft, and this crankshaft and camshafts are connected by a chain. It is called timing chain. Timing chain is needed to synchronize camshaft and crankshaft, and this bottom sensor is crankshaft position sensor, and these three sensors are connected to ECU, and in turn ECU will control fuel injectors and spark plug. In this diagram you can see I have taken 3-cylinder engine, and if I assume this side to be intake side and this side is exhaust side, that is, for each cylinder we have 2 intake valve and 2 exhaust valves. The working of the CMP sensor is similar in case of petrol engine and diesel engine. The only difference is in the diesel engines we won't have spark plugs. Now you might get a question, what is the need for camshaft position sensor when we already get the information from the crankshaft position sensor? As we learned earlier, from the CKP sensor we will get to know either a cylinder has reached a TDC or not. That is, it is limited to a single cylinder. But in case of CMP sensor, it can give you the information of individual cylinders. That is, whether a cylinder 1 is in intake cycle or compression cycle or combustion cycle or exhaust cycle. And similarly for these two cylinders as well. Now let's understand this in detail. Now if you observe this diagram, it has few gears on it, and usually this will be mounted onto camshaft, and I have numbered it as 1, 2 and 3, and this is CMP sensor. It has 3 wires. First one is power, usually 12 volts, second is reference ground, 0 volts, and third one is signal output, usually in the range of 0 to 5 volts. Now let's assume this gear is turning clockwise. As soon as this tooth comes in front of this sensor, a voltage will be induced. That is, here you can see a spike, right? So every time this tooth comes in front of the sensor, a voltage spike is induced. So here you can see these two are close together. That's why these two spikes are close together, and since there is a gap here also you can see there is a gap, and again a spike, then a gap, and again spike, and so on. That is, if you take this as a 360 degree and it is divided into segments, that is, this is x degree, this is y degree, and this is z degree. A manufacturer may assign this first tooth to cylinder 1. That is, as soon as this gear passes, you can predict the cylinder 1 is in compression cycle, and as soon as we detect second spike, we can synchronize it with the second cylinder and the third cylinder. Since the x, y, z are different in degrees, so we will get different spacing in between these spikes. Usually this will be in the analog format and it will be converted to digital signal using ADC, that is, analog to digital converters. Usually it will be represented in PWM format, that is, pulse width modulated signal. Here in the digital signal you can observe whenever there is a spike we get a square wave. Here you can also observe the width or time between the two square waves is different. That is, this width is different than this width, and this width is different than this width. That is, this gap is time between gear tooth 1 and gear tooth 2, and this gap is time difference between gear tooth 2 and gear tooth 3, that is this z degrees. This is how we can recognize each cylinder's cycle, and the redundancy of the crankshaft position sensor helps in accurately determining the timing. Now let's understand what are the uses of using CMP sensor. First I will take spark timing and fuel injector timing. As we all know, when a cylinder is at the end of the compression cycle, fuel is sprayed. After beginning of the combustion cycle, a spark is initiated. These two sequence timings are provided by the ECU with the input of camshaft position sensor. And if you observe here, I have mentioned this as cylinder 1, this as cylinder 2 and this as cylinder 3. That is because engine will have a firing order. That is, first fuel will be sprayed onto cylinder 1 and spark is initiated and combustion takes place, and next it will jump to cylinder 3, that is mentioned as 2, and combustion takes place here. Then it will come to this cylinder. That is, firing order is 1, 2, 3, 1, 2, 3. And the next point is start of ignition cycle. That is, when you are starting the engine, the position of the camshaft and the crankshafts are unknown. After first crank, the ECU will receive the initial position of camshafts via CMP sensors. The next one is cylinder selective knock. Whenever knocking happens at a particular cylinder, ECU will be able to adjust the spark timings using the CMP sensors. Usually the timings will be advanced in case of knocking. When it comes to types of CMP sensor, usually there are two types. First one is Hall effect type, the second one is inductive or magnetic type. The one I explained here is Hall effect type. Usually it will have 3 wires, and Hall effect types are externally powered. The Hall effect type sensor internally contains a magnet and a Hall effect element. It usually generates a voltage whenever it detects a changing magnetic field. Usually the raw output will be in the form of analog voltage, and it internally contains a ADC which converts it to digital. And when it comes to inductive type, usually it will have 2 wires. It doesn't need an external power. Internally it contains a magnet and a copper wire wound around it. And whenever it detects a changing magnetic field, that is, whenever a gear tooth passes in front of that sensor, a voltage will be induced inside the sensor. And similar to Hall effect type, it will be later converted to digital signal. Now let's understand what are the symptoms of faulty sensor. First one is MIL, that is malfunction indication lamp. That is, whenever a ECU detects a fault in this system, it will trigger a fault code. Usually the CMP related fault codes are permanent in nature. Second one is no start. That is, if a CMP related fault code is present, the engine will not start no matter how many times you crank it. Engine will only start after solving the issue and clearing the fault codes. You can even observe rough idling or poor performance if there are issues with the camshaft position sensor. There can be misfire or knocking in particular cylinders where the CMP is not able to accurately determine TDC of the cylinder, and as the result of misfire and knocking, we will have poor emissions. That is, either it can have a black smoke or harmful emissions. I'll give you few reasons why this sensor becomes faulty. The first one can be oil, dust, grime which settles on the sensing part of CMP by forming a layer, or it can have a wiring damage, or a signal wire can be short to ground or short to VCC. I hope you understood my explanation on CMP sensor. If you found this video to be informative or learned something, please do like and subscribe for future videos. If you have any doubts or if you need further explanation, or if I made a mistake, please do let me know in the comments or message me in the Instagram. I'll meet you in the next video. Bye bye.